right, thank you, Jim. In addition to being the president of the Heartland Institute, I'm also on the board of the American Conservative Union. So if you have reactions to how the conference has been going so far, I hope you'll let me know. We really depend on feedback from everybody so that we can improve this program year after year. Man-made global warming is the topic of this breakout session, what progressives nowadays call climate change. It's the mother of all environmental scares. If what the advocates of man-made global warming say is true, we would need to reduce emissions of carbon dioxide and other greenhouse gases by 80%. And by we, I mean the entire world, not just the United States. If the United States reduces its emissions by 80% and the rest of the world continues to increase their emissions, as is entirely likely, it will have been a futile exercise. If the progressives who talk about global warming are right, global warming will cause floods and droughts, hot weather and cold weather, extreme weather, or maybe less extreme weather, extinction of species, hurricanes, sexual confusion among frogs. There's an extensive literature, literally hundreds of things have been attributed to global warming. So the science on the issue, I think, has clearly been politicized. It's been turned into a political cause rather than a scientific research agenda. The Heartland Institute, starting about 20 years ago, started to look under the hood at the science behind the global warming scare. And what we found is that there was no consensus on the role of human emissions on climate. There was actually, most scientists thought that most of the changes in climate over years are caused by natural forces. There's half a dozen different theories about what might cause climate change. There's a widespread skepticism in the scientific community about the reliability of computer models and their ability to forecast future climate conditions. So when you actually look at the science, when you get past the rhetoric and the advocacy of environmental groups, what you find is a lot of disagreement, a lot of debate, and a very young science that has not reached any conclusions yet. One of the contributions that the Heartland Institute has made to this debate is to host a series of international conferences on climate change. We've held 8 of them so far. Over 3,000 people have attended. Over 300 scientists have given presentations. All of those presentations are available online at the Heartland Institute's website at www.heartland.org. At our 7th conference last year in Chicago, we had a panel that was just a huge success. It consisted of astronauts, former astronauts, and former NASA scientists and engineers who were taking issue with NASA's advocacy of extreme global warming alarmism. And these were very distinguished people, heroes, really, of the 20th century, who were coming forward to protest the politicization of science by the agency that they had worked for. So that panel was so successful that we asked these guys to come back here to CPAC and make a presentation. And I'm very, very proud to say we have 3 of these guys with us today, Walter Cunningham, Harold Duarn, and Thomas Meismuller.
Just say Johnny.
Tom is what we're going to call him. I'm going to give you a quick introduction to Walter, and each of these guys is going to talk for about 15 minutes. I'll come up and introduce the other speakers at the end of each presentation. Walter Cunningham has bachelor's degrees and master's degrees in physics from UCLA. He's all but dissertation for a PhD in physics from UCLA. On October 11 to 22 in 1968, Walter Cunningham piloted the lunar module on Apollo 7, the first manned flight test of the 3rd generation U.S. spacecraft. Walter is also the founder of the Earth Awareness Foundation, which he started in 1970. He likes to point out that that precedes most of the modern environmentalist movement. He's the author of a book titled The All-American Boys in 1977. He's been active in a whole range of scientific endeavors, research, and investment activities since his time as an astronaut. Please welcome Walter Cunningham.
Thank you, Joe. Joe, just one correction. We didn't have a lunar module on the first test flight of the Apollo program.
You still with a pilot.
Yeah, I had that title, you're right. So, well, as Joe just described, I am not a climate scientist. I am a student of environmental science, and I like to think an informed critic. And I can tell you from space, our home planet does appear fragile, but right here on Earth, it really is plain how well humanity has adapted to climate changes over the last million years. And we will continue, well, sorry about that. Got to be careful what I touch here, Tom.
That's right.
Okay. And I'm not here to make the technical case against human-caused global warming, anthropogenic warming, AGW, climate change, climate disruption, or whatever is the current catchphrase being used to promote the alarmist cause of global warming. These are all code words for governmental control of energy consumption and consequently our standard of living. Global warming alarmists focus on the small temperature increase since the Industrial Revolution, and they say that we humans are controlling the temperature of our world. They have sold the media and the public on something that they invented called consensus science. And the media has bought into human-caused global warming. Skeptics of the alarmist claims, like our panel here today, are characterized as climate denialists or fake experts or against climate change, which no sensible person can deny. Instead of the alarmists presenting data to prove their hypothesis, we skeptics are challenged to disprove their hypothesis. Well, we really are realists, not denialists. And while scientists may be best qualified to deal with the scientific and academic aspect of this problem, there is a practical issue that really affects us all. And I'm referring to the financial consequences of actions taken based on bad science. We are caught in a war to avoid the lowering of our standard of living and the economic destruction of our world. And you've already had a preview. Here's the only evidence I've found that might support the alarmist case. The temperature of our Earth has been changing for the last 4.8 billion years. Here's a chart of the last 600 million years, for example, and I've highlighted a couple points. This is a very readily available chart, and when you get a chance, take a look at the places I've circled here, and you can wonder how they came to the conclusion they did. Note the temperature and the carbon dioxide today. Or you can look at the last 2,000 years and look at the temperature today relative to what it's been for the last 2,000 years. Well, the public really doesn't know what to believe about human-caused global warming. The alarmists have been hammering at us now for 30 years, and most of the media are what I call true believers. Politicians, in the absence of knowledge and understanding about climate science, have put themselves out on a limb from which they find it difficult to retreat. Empirical data collected over centuries evolved into a provisional theory of climate change. Scientists have long known that the sun, oceans, and variations in the Earth's orbit are the principal drivers of climate change. While we may not fully understand all of the mechanisms or the interactions involved, after hundreds of years, it became the de facto theory of climate change. In essence, the sun is a dominant factor in our weather and climate. Well, scientists are always questioning accepted theories, even those that have evolved over centuries. But for a new hypothesis to modify or replace an accepted theory, it must be supported by the appropriate data. In the late 1980s, a small group of individuals became concerned about the Earth's temperature and what it might do in the future. I hesitate to call them scientists because they apparently had little appreciation for the process by which their guess about future temperature increases could achieve scientific acceptance or rejection. They hypothesized that warmer temperatures were a threat to humanity, that carbon dioxide levels were abnormally high, that higher levels of carbon dioxide were bad for humanity, and that humans were capable of overriding natural forces to control the Earth's temperature. Well, only 30 years ago, some of the same scientists now pushing human-caused global warming were arguing that the imminent threat was global cooling, which could eventually trigger an ice age. Their new hypothesis that human-generated carbon dioxide was responsible for global warming was a challenge to the accepted theory of climate change. For a new hypothesis to be accepted by the scientific community, it must be confirmed by considerable evidence and must survive all attempts to disprove it. Well, the hypothesis that human-generated carbon dioxide is a principal driver of the Earth's temperature has not satisfied either of these criteria. However, the alarmist hypothesis did gain immediate traction with the environmentalists and the green movement, with the media, and eventually with many politicians. In the absence of supporting data, alarmists are appealing to the public, where politics, media, and money play important roles. Well, this is a controversy that should not be resolved in the court of public opinion or the political arena. It should be resolved in the court of scientific inquiry, based on empirical data. Some examples of why that's where it should be done. Alarmists like to refer to the correlation between temperature and carbon dioxide levels. Well, here's some empirical data dating back 130 years. I would say, what correlation? Are they talking about correlating with the carbon dioxide there or correlating with solar activity? Besides, correlation is not causation. For example, there's a pretty good correlation between the number of pirates and the temperature for the last number of years, going back to about 1820. So you'd think that they ought to be arguing that we ought to be increasing the number of pirates in order to lower the temperature. Well, if you want to look at causation, temperature changes have preceded carbon dioxide level changes by 500 to 800 years in the past history. And that observation is much more consistent with the existing physical science laws and the existing theory. The one thing that alarmists like to cite in support of their simplistic hypothesis are the mathematical models which they developed to prove that human-caused carbon dioxide is a dominant factor in controlling the Earth's temperature. Well, unfortunately, climate models have never successfully predicted anything. Models are based on assumptions, and that's opinions. And if the bases for those assumptions are wrong, the results can never accurately predict future behavior. We should be emphasizing that models are not data. As realists, we always focus on the empirical data and the scientific process, neither of which support the hypothesis that alarmists have been dreaming up. So they resort to alarmism, consensus science, politics, and money. And they have convinced most of the media that human-caused global warming is an accepted scientific theory. In another ploy to scare the world into throwing away hundreds of billions of dollars in a fruitless effort to control the temperature, they appeal to the public's fear with, what if carbon dioxide is responsible for the temperature and we do nothing? Well, with history, facts, and scientific theory all on the side of us global warming realists, why is climate change such a controversial issue today? Well, the war that's being fought, it's being fought on four intellectual fronts: the scientific front, the media front, the public perception front, and the political front. Climate science realists have been fighting on the scientific front, and they appear to be winning the scientific battle. Today, now, we need to focus our attention on public understanding of the issues. The real battle today, and where we appear to be losing, is on the media front. The media plays the most influential role in the public's perception and, to some degree, with the politicians. He who controls the vocabulary controls the argument. The alarmists have seized the semantic high ground, a tactic that has helped move the subject from the scientific arena into the political and economic arenas. The media, the public, and most of our politicians have little scientific or technical background, with some rare exceptions, and they show very little interest in gaining it. That does not prevent the media from playing a major role in this fight. Journalists are in a position to influence a great many readers, and many of them are aggressively pushing human-caused global warming. Alarmists refuse to accept that today's weather is within the realm of natural climate variability, and they are loath to admit how little control man has over nature. That is why global warming is sometimes referred to as a religion with the alarmists. To take global warming on faith, you have to reject the observable scientific reality and what we have learned about climate change over several centuries. And they have to embrace the unproven hypothesis of humans being responsible for global temperature changes. True believers in human-caused global warming cannot be reasoned out of their position because it wasn't reason that got them there in the first place. It was emotion and politics. The challenge at this stage in this war is to engage the alarmists on the media front and to bring the media and the public back to reality. The public and the media should not just buy what others are telling them. A nuclear physicist, a great nuclear physicist by the name of Leo Szilard once said, if one knows only what one is told, one does not know enough to be able to arrive at a well-balanced decision, unquote. Well, first and foremost, the media should look at the data themselves. And I'm not talking about just the data put out by the alarmists. They should make it clear that the argument is not about climate change. It is about the cause of climate change. When writing and speaking, we skeptics or realists, we should consistently refer to the alarmist claim as human-caused global warming. That's why I used it so many times just this morning. We should make it plain that alarmists are pushing a hypothesis, a guess based on their observation. It is not a theory. At this stage in the war on human-caused global warming, the battle for public perception may be more critical than the scientific fight. And this battle should not be beneath the dignity of climate science realists, especially when they are dealing with the media. So climate science realists have got to be doing some of these things with the media. Each of you needs to look at the data and form your own opinion. Don't just buy the opinions of others. And that includes me as well. Look at the data yourself. If you can read a historical graph, you have most of the tools necessary to decide the climate controversy for yourself. Well, I have looked at the empirical data and concluded that the evidence does not support the alarmist hypothesis. And I would tell you that the last place to look for objective data is the United Nations Intergovernmental Panel on Climate Change. Having followed what I have been preaching myself, I will close with some of my conclusions. One, based on the historical data, there is no reason to be concerned about today's temperature or temperature trend. Two, human-caused Human-caused carbon dioxide is a vanishingly small factor in global temperature when compared to the natural factors, and that includes the naturally produced carbon dioxide. 3, higher temperatures and higher carbon dioxide levels will save more lives than lower levels. And 4, it is a fantasy to think that we can have a significant influence on global temperatures. Now, you've got to come up with your own answers. Thank you.
Set the,
He just mentioned, that was a terrific talk, Walt, thank you very much. He mentioned the fact that correlation is not causation. I'm reminded of the famous story, there's a very close correlation between the sale of station wagons and giving birth to a child. And in fact, the sale of a station wagon usually precedes by about 6 months the birth of a child. But buying a station wagon does not cause people to become pregnant or to have children. Walt is going to be signing a little booklet that he had written a year or two ago. There's, I believe, everyone was handed a copy of this when you came into this room. There are additional copies on the table out there. He'll be signing them, if you like, when this panel discussion is over. He also talked about finding other research besides the IPCC report, and the best source of research is the Non-Governmental International Panel on Climate Change, otherwise known as NIPSI, and they've been producing reports. This is the first report that was published in 2009, Climate Change Reconsidered. It's available online, the entire thing. It's an immense piece of research. There's over 3,000 peer-reviewed studies that are cited in this report. If you just Google NIPSI, you will find this, or Climate Change Reconsidered. It's a terrific reference. All the research that the IPCC didn't think worth sharing with the public. Our second speaker is Dr. Harold Duarn. Goes by Hal. Harold began his career with NASA in 1963, spent 16 years with NASA, followed that by 9 years at the Reed Tool Company developing advanced energy exploration drilling technology. While at NASA, Hal developed the Apollo Lunar Module landing dynamics software that was used to guide landing gear design. He performed docking dynamics studies for the Skylab program and led the Space Shuttle team that successfully eliminated unstable vibration coupling of the shuttle structural dynamics and rocket engine thrust oscillations. You'll all be happy to know. In retirement, he's a consultant to NASA and to commercial rocket developers. He was on NASA's standing review board for the Mars rover Curiosity, entry, descent, and landing last August. Please welcome Hal Duarn.
Thank you, Joe. I've only been a serious student of global warming for maybe 2 years, and I'm here to report on a group of us down in Houston with participants from all over the country. Tom lives in Maine, but he's part of our group. Some of you may have heard about a year ago, I think it was a year ago, we wrote the NASA administrator, about 50 of us, Walt and many of his astronaut colleagues, retired engineers, that we were really uncomfortable with alarming claims coming out of NASA employees. Then we didn't see the data to back up what they were saying. We didn't get a very good answer. So a group of us decided to look into it in much more depth, and I'm here to report on what we've found. How do I get this? The arrow key, okay.
Yep.
Good. So the group that convened February of 2012 We're an all-volunteer group. We have more than 20 active. I've got more than 30 on my standard distribution list. We are scientists and engineers, mostly Apollo-era veterans. We have some academics. You know, I'd say about 10 of us have doctorate degrees, but we all have more than 40 years' experience looking at data, interpreting data, and making critical decisions that involve human safety, primarily astronaut safety. So we are very concerned about looking at data and making the wrong decision. And so we've applied that experience and processes that we have been taught and that we believe in that you use when you make a decision that has really potentially adverse consequences. We were concerned about NASA's public statements regarding AGW, and Walt has used this term, anthropogenic global warming. It means human-caused global warming. I didn't write out all the words because I didn't want to use up the white space on my chart, but AGW means human-caused global warming, and that's what we're mostly concerned about, is trying to understand the extent of it. So we used proven data analysis processes that really served me well at NASA, but they also served me well during my oil field career for 9 years. These are universal processes that work. So we are very precise in the way we define a problem. With that definition, we have a surefire process to find root cause of a problem, and we're very disciplined in decision-making based on the root cause analysis. We have finished our one-year study. We haven't finished, we've just finished our original goal. And our original goal was to answer the question, to what extent is human-caused carbon dioxide causing global warming? It may be causing a little bit, but let's nail it down. If you look at the technical papers, you know, the projections are from insignificant to alarming. Well, you can't make a decision with that kind of a uncertain projection. So we wanted to try to nail it down for ourselves. We've published it's a one-page summary of our conclusions, and I'm working on getting a report out, but I tell you, it's hard to get a consensus among 20 scientists and engineers when you have a subject that is so complex and still so uncertain. So we're working on the report, but we all agreed on these 6 things that we concluded, and nothing there is alarming. So I urge you to go to our website. It's got a lot of stuff on it that we've been putting up there for the last year of our study. But the one that has our one-page conclusion is somewhere it says preliminary report, kind of on the left-hand side. So the bottom line, and this is the first conclusion of our 6, the science on the extent of human-caused global warming is not settled science. And what I've noticed in debating this issue with green energy lobbyists recently is that they push this idea of 97% of scientists agree. But when you really look at the statistics they quote, they're very shaky. They don't really represent what scientists believe about AGW. They realize the data on the climate is going against them right now, and they don't want to talk about the science. They want to talk about how many technical papers agree. We've read those technical papers. Joe showed you the NIPCC report. We've read that report, studied it. We've studied the IPCC reports. We've had a number of scientists from either side of that debate come speak to our group where we could question them. And that's how we reached our conclusions. Much the same way we reached conclusions in the Apollo program when we needed an answer to a question and you couldn't find it in a book. I mean, we were really exploring in those days. So these are the methods that we used. So I want to talk about, and Walt really gave me a good entry on this, and I didn't know he was going to do it. You got to look at the data. So when I look and worry about global warming, there may be other problems, but one problem we always hear about is sea level rise. For that to happen, we're going to have to melt the ice sheets in Greenland, or we're going to have to melt 90% of the fresh water on Earth, which is trapped in the ice of Antarctica. And one thing in preparing for this talk that I haven't really run by my colleagues, but I'm going to dump it on you, global warming isn't a problem. If there's a problem, it's going to be local somewhere. It may be a collection of local problems, but you can't really define a global problem. You've got to define it locally, and I'm kind of introducing this idea for the first time to you people. So locally, here's a great ice core. This is data from the National Oceanic and Atmospheric Administration. It's right in the center of Greenland, and it gives us a good picture of what's been happening to climate in that area, that local spot, for over 40,000 years. I'll give you the reference because I like to reference the data sources. Now, there are many such ice cores, and I'll show you data from a bunch of them. But this is one that kind of simplifies the graphs for me. This is what I'm going to talk about is we're now in a period of stable climate. For 10,000 years, we've had stable climate. And what I mean by stable is this part on the right with the two little bars that show temperature variation. This vertical scale is in degrees centigrade, average for a year, and the horizontal axis is time, where 0 is 0 AD, the time of Christ. So if you look back, say more than 40,000 years, it was much colder. And we were going through, a series of pretty radical changes in climate at that location in Greenland. But all during this time, Greenland was building ice mass. And then we warmed up after the last glacial maximum, which occurred, let me get this. I'll put my glass on to see the control button. Is it command or control?
Control.
It's written out. Yeah, it's abbreviated on my computer. You go back. Okay. This is about 12,000 years ago. The last glacial maximum was about 20,000 years ago. So we were in this area where we had the largest extent of ice covering New York City with a couple miles of ice back in this time. But for the last 10,000 years, we've been stable. So this is the backdrop of the current climate change that we want to assess. How are we doing with this relatively stable history? And I'm going to focus on that. Now look, like Walt said, if you can read a graph, that's all you need to understand the issues with climate science. Look at the data. If the current temperatures are not out of bounds, what is it that we're worried about? We're worried about some hypothesis, some projection, but not actual data. So I'm going to use what I was taught at NASA about how to define a problem. If you're going to talk about a problem, you have to have a very precise problem statement. And that problem statement says you must define the problem in terms of a harmful deviation from normal expected behavior. You know, being out of limits or headed towards out of limits. We hear about red lines and blue lines. Well, we're looking for deviation of a process from normal behavior. This is that last 10,000 years of stable climate. All this area in here. Walt had on his plot, I have a hard time finding my cursor here. Okay. He had this area, that low temperature point. So notice at 0 here, you can see I have a hard time. But anyway, let me walk over here. Notice at 0, this is 2,000 years ago, the time of Christ. We've got a warm period in this ice core data. In that local spot, temperature was rising. It came down, and then it went back up at about 1,000 years ago. This period, it's known, the first peak was known as the Roman warm period. The next one is known as the medieval warm period. And then we had a little ice age that Walt showed on his chart that started before 1600 and ended about 1715. It started warming up from the little ice age way before the industrial age. That initial warming wasn't caused by CO2. None of these oscillations were caused by carbon dioxide. Carbon dioxide was constant throughout that period. And if somebody's going to tell me that carbon dioxide is causing warming with their model, then I want their model to explain all of that natural stuff that was going on. Because if you can't model the natural stuff, how do you separate what carbon dioxide is doing now from the natural thing that must also be happening? And if you read the statements, more and more the IPCC authors are talking about the contribution of natural effects. This is the natural effects. So I would say problem, what problem? This thing, right at the end here, you can't get, say, the last 50 or 100 years from ice cores. So it's incomplete, but I'll show you that. This is basically the start of the hockey stick, way out here on the right. And I'll show you the hockey stick is still within these bounds. Okay, so this is kind of new, but I believe it, and I got to convince my colleagues that it's true. But any problem that we've got is going to be local, not global in nature. You know, the problem that New Orleans has with hurricanes is not a global problem. It's a New Orleans problem because the city's below sea level, and they got to put levees up to protect it. So if sea level's rising, it's not a global problem. It's not happening in the Rocky Mountains. It's going to be on the coastline where the solutions could be many options other than trying to control CO2 emissions. So ask yourself, what locality or region has a harmful warming problem? Do you have a problem where you live? You know, it's hot in Texas, and we always thought the sun was causing the temperatures to be hot in Texas. But we didn't go try to dim the sun. You know, we invented air conditioning, and it works great. So that's how we're dealing with our local problem. You know, the Canadians have a different problem. So local problems will most likely require local solutions that might be a lot less expensive and easier to implement. Let me ask you, does the USA have a problem because of global warming? In fact, if you look at the temperature data, even the warmest scientists say, well, the continental USA hasn't warmed while the globe was warming. Don't think we have a problem. When we define a problem and go for root cause, we answer a lot of questions having to do with what is the problem, where is the problem, when does the problem occur, how much or what's the extent of the problem. And it's this information about what is having the problem versus places that aren't having the problem, similar places that aren't, that lead us to root cause. I submit that nothing close to that kind of a rational thought process has gone into the hypothesis that CO2 is causing a problem. Even if CO2 emissions can be shown to be harmful for some localities, global solutions are difficult to implement. This is not my original question, but I can't imagine our president is really thinking he's going to solve a problem by unilaterally controlling CO2 emissions in the United States. How could our unilateral efforts to control CO2 emissions be an effective solution if China and India did not agree? We could do it, but it won't solve the problem if there is a problem. Ask yourselves, what other local solutions to local problems could be more effective and certain of working to achieve that desired result? My point here is, everybody's just talking about controlling CO2, but there are other ways to solve a problem that would be more certain. There are other ways to solve a warming problem if it was natural. Okay, here's more ice core data, and I know it's hard to understand. The only thing I want you to take away from this slide is here are ice core data. This is NOAA data. I found it in a book by John Kerr entitled The Inconvenient Skeptic, and if you're interested in climate change, read John's book. John is not a professional climate scientist. He's an engineer like me. He works in the semiconductor industry, and he lives in Boise, Idaho. And he has done an amazing job of compiling all this data and making good sense out of it. I met John at the Heartland conference in Chicago last May, and that's when we first found out about his book. I actually had it with me, and I am so impressed with what this young man has done. I want to show you what his book looks like. He self-published this book, and you can get it from his website, which is theinconvenientskeptic.com. All of the illustrations in this book are free to you online to look at, but his interpretation is in the book, and it's an amazing book. We had John come down to Houston and give us a 2-day seminar on his book, where all these veteran rocket scientists could question him and probe. And, he just left us speechless. He knows the stuff. Okay, sorry. So anyway, the point here is the temperature is oscillating between plus and minus 2 degrees all over the world, or at least in Antarctica and Greenland. And we're well within bounds. That's the same data dimmed out. Here's the current data in the red. Just like Walt showed. We're way within bounds of what's been going on for 10,000 years. At this local spot. This is the new hockey stick, which maybe Tom will have. This is the latest data, okay? The up part was the original hockey. We were cooling the last few years.
Steve Goddard the credit for it. Steve Goddard.
And Steve Goddard was the guy that we put this on the internet a few weeks ago. So this is the conclusion of what I've been talking about. To determine the extent of AGW, the characteristics and causes of natural climate cycles must be more completely understood. Climate models must be improved to correctly model natural climate cycles. And the models must be validated. They must be shown to predict something that Mother Nature does. They haven't been right yet. So to wrap up, there is no current climate crisis requiring swift corrective action. Let's take the time to gather more data, to get the models corrected and validated, to clearly and specifically identify potential problems, and to consider a wider array of problem-solution options. All of these ideas are embedded in our one-page summary of what the Right Climate Stuff team has learned in the last year. Thank you.
Thank you, Hal. That was terrific. I wanted to quickly recognize Wolfgang Mueller is here. Wolfgang, stand up and take a bow. Wolfgang organized our 8th International Conference on Climate Change in Munich. And I believe Wolfgang is interested in holding more events in Europe. So if you're interested in taking a flight and doing a climate change conference in Europe, please talk to Wolfgang at some point. And Tom is our next speaker, Tom Weissmuller. Tom trained as a meteorologist at New York University and at the Royal Dutch Weather Bureau in Amsterdam. He then worked for 5 years as an intern for NASA throughout the agency, both before, during, and after the moon landings. He is routinely invited back to give science and meteorological lectures at NASA field centers. Tom is also the past president of the NYU Alumni Association. He's received special recognition from the Council of the City of New York for his contributions. He's one of the guys who's putting together the entire Climate Right Stuff effort. Please welcome Tom.
Thank you, Joe. The slide you see here is what you see if you ever make a presentation at Johnson Space Center. Everybody gets to see this slide because that's what NASA is still all about. They want to see data, hard data. Now I'm going to ask you a question. How many of you in the audience here, a show of hands, have seen the CPAC ad on temperature? Ooh, not enough. A couple. All right. Let me see if I can make this work the way it's supposed to. This is what it looks like. I think this is shown on a billboard sometime someplace out of DC. And basically it says, there's been no global warming for 16 years. Actually, we're talking about air temperatures. All right, we happen to live in the air, so it's nice to know that there's not a lot of warming. This is true. It's hard data. They're using Hadley 4, and you can kind of see that in the bottom here. I happen to not like Hadley 4, and I'll tell you why later on, all right? But Hadley is the British Climate Research Unit. What I'm going to try to do is a couple of things. I'm going to punch some holes into some things you've heard about recently. Greenland's ice cap is melting, stuff like that. I'm going to give you some discussion about the record open Arctic and what implications that has. So you've read that in the newspaper too. We're going to give you some background on it. I'm going to talk about the human impact in CO2. Where's the CO2 really coming from? I want to make sure you all understand that and that you're looking at hard data. So let me go to the first set of slides. This is the headline you saw in the New York Times. Greenland is melting. This happened to be in in July. And in July, it just turned out that a blob of warm air had crossed over Greenland and started some surface melt. About maybe an inch of the snow on Greenland had melted all over the continent. Now, this is pretty significant, but it's also not the first time it's ever happened. Ice cores that we get in Greenland show that this happens routinely. Every 100 years or so, you get one of these total 1-inch melts and things like that. It's not that serious. If I look at what's really happening in Greenland, you notice the red areas here. Greenland is, maybe I can highlight this better with the edges of Greenland are actually melting at a fairly rapid rate. However, the interior of Greenland, which occupies a much greater area, is actually accreting snow. Greenland is relatively imbalanced. Even as the edges lose, the interior is gaining. And I want to see if I can show you this is the summit station in Greenland, all right? The summit station is about 10,000 feet up. It's about 2 miles of ice underneath it. And you notice it's built on stilts. Now, why would they build it on stilts? Because it snows so darn much, they have to keep on raising the building so that they don't get inundated. Here's another look at it. And you can see the stilts. They work very well. This is the summit station on August 31st this year. It's taken by webcam. You notice you don't see the stilts anymore. They're in the middle of a blizzard. The little flags you see are so that the people who walk between the buildings don't get lost in the snow. So after Greenland had 1 inch of melt, they picked up about 4 feet of snow all this summer. So the seriousness of the Greenland melt really isn't very serious. And Greenland is still gaining mass. Here's the geography of Greenland. I'm going to try to show you. Right here is where we had a low-pressure cell go over Greenland at the end of August and dump those 3 and 4 feet of snow. And the way the meteorology of the area works, low-pressure cells circle like this, and they drag in moisture off the open ocean here and just dump it on Greenland. Happens every year as the northern jet collapses around the pole every summer. Those storms come on Greenland and add snow to Greenland. Now, here's the warming argument. The oceans are getting warmer, all right? The fact is they are getting warmer. What heats the oceans? It's called the sun. However, the rate of warming has decreased. You notice the slope of this curve actually decreases as you get toward this end. There is still oceanic warming going on, but not that much. What are the results? Well, we're going to show you. This is, by the way, Joe asked me, he said, don't have too many slides, all right? Well, I'm going to show you about 1,500 slides. And they're going to happen right now, and you're going to see them in about 22 seconds. And the way this works, I want to explain what you're looking at here. Anything that is red is ice that's been on the pole for more than 5 years. This is the ice age. The dark blue is called pack ice. Pack ice forms and disappears every winter, every summer. It's frozen seawater, and it disappears in the summer. And down here in the bottom here, you notice 05, 1982. What does that mean? I can make it a little bit bigger here. It is the 5th week of 1982. That's when this image was taken. Now back up a little bit. You can see the region here. Here's Greenland. You're going to see the warm water ocean currents come streaming up through this gap here between Spitsbergen and Norway. And the reason I want to show you the geometry of the area is that it happens to be a fairly shallow area right here. However, the ocean heat content is in this top layer. This is about maybe 100 feet deep. Top 30 feet is where the warmth in the ocean is, and that streams over this sill and goes into the Arctic Ocean. And if I back out a little bit, you notice here you have a deep water channel exiting. And you're going to see that motion when I run these slides that I'm not really supposed to show you, okay? So now watch what happens when I put them in motion. 1985, now 1986, and you can see the weeks running by, right by here in the corner. Here's the warm water streams in, pack ice forms, disappears, forms, disappears. You're looking at years now, going by really quickly. You notice the multi-year ice, the older ice, is now being bunched up against the Canadian islands here. The warm water is still streaming in here and melting the pole. By 2007, it's all gone. Now I'm back in 1982 again. I'm going to show you the next 22 seconds. You're going to see it disappear. By the way, coming out here, these are icebergs. as they come out here. That multi-year ice is fairly thick, and it can sink ships, including the Titanic and other things like that. Again, pack ice forms, disappears, forms, disappears. So now we're in 1999, now you're in 2000, you're skipping through time here. This is a pretty neat time machine. And now we're in 2007. Now I'm going to back up. This is the 21st week of 2007, all right? This is the 25th week. This is the 29th week. Now we're halfway through the year. You notice, again, the multi-year ice in 2007 is all bunched up against the Canadian islands. The rest of the Arctic is opening up. In 2007, we had a record open Arctic. We were losing about maybe 100,000 square kilometers a year. In 2007, we lost 1 million. The effect of that was extensive, and I'm going to show you what the effect is. And by the way, you think this is over? No, not really. In 2000, this is 1982. Look how much multi-year ice is all over. This is 2010. Where's the multi-year ice? The multi-year ice is, again, Canadian islands. This happens to be 23rd of September, which is the maximum open in 2010. So we have lost a lot of ice in the Arctic. And you say, oh my goodness, this is evidence of global warming, isn't it? Not quite. This is a 3-slide show taken from an ESA satellite. This is Greenland. The black dot is over the pole. It's an artifact of how the pictures are taken in the questions and answers. I'll tell you later on how that works. But you notice the big chunk that's going to be gone here in 2007. Huge open part along Asia. 2006, here's 2007. Now, what are the consequences of an open Arctic? First of all, the Earth rotates from west to east. In the polar region, the Earth rotates under its atmosphere. So you see the Earth rotating like this. So anybody standing here in Siberia or here in Greenland, the wind is always coming out of the east. They're called the polar easterlies. Again, the Earth is turning under its atmosphere, and you're feeling wind. Well, if you're standing here, and all of a sudden you have an open ocean, you have what we can call lake effect snow. Now it's ocean effect snow. For the first time in many years, the Arctic opened up and allowed that moisture to escape. Remember before, the storms coming on Greenland was sweeping moisture off the ocean, and you get 3 or 4 feet of snow landing on Greenland. Well, this is the Arctic sea ice extent graphic. You notice 2012, which is the red line here, was lower even than 2007, which is the black line. So if this was the record open Arctic in 2007, you can imagine what happened last year. It was huge, huge open Arctic gap. Now, I'm going to explain this graphic. First of all, the floating ice is not purple, okay? University of Illinois likes to color anything that floats magenta. It's still white. It still reflects sunlight. You notice this is September 23rd. Very, very little snow here because it's still summertime, maybe the end of summer. You have a huge open hole again in the Arctic Ocean. And here's the significant thing. In September already, the open Arctic has allowed the polar easterlies to sweep snow off of and deposit it on eastern Siberia. This is very, very early snow. The open Arctic allows it to happen. When you have that snow on the ground, it starts reflecting incoming sunlight. It's called albedo. Albedo is the reflection of sunlight from either cloud or snow. Now, I'm going to make some comparisons in the next couple of slides between 2007, which was the previous record, and 2012 last year. So here's your first comparison. This is now taken October 10th, 2007. You notice in 2007, the Arctic was open. Snow was being deposited in northern Asia. But take a look at 2012. More snow. Much more snow than in 2007. And that was the record. 2008, by the way, according to the satellite data, was the most snow cover extent ever before seen in the Northern Hemisphere in the 42 years that they had satellites in orbit. That was 2008. 2012, getting worse. We're getting early snow in northern Asia. The Arctic is still open. Snow is coming on there. That snow, I'm going to take, here's a slide 1 week later. This is the 18th. Look at the difference. Asia is beginning to be inundated with snow. 2007 had a lot. Anything gray, by the way, is like 6 inches of snow or less. It's still white. It still reflects incoming sunlight. So the energy still is lost to the earth. But look at the difference in 2012. This is just this past fall, and that was only in 1 week. Here is November 10th, 2012. Well, November 10th, you notice the Arctic is now totally frozen again. It's cold. It's really cold up there. It's already about 40 below zero. The Arctic Ocean is frozen, but the damage is already done. Asia is almost totally snow-covered. All the sunlight coming into Asia now gets bounced off the Earth. 70% gets bounced back into space. And here's the trick. You know, people used to say, well, carbon dioxide traps heat, right? Well, carbon dioxide traps long-wave radiation. Most of what comes in from the sun is short-wave. Comes through the CO2 on the way down, and on the way back up, it pierces it at the same wavelength. It doesn't get trapped. This is what albedo looks like. I'm going to make this a little bit larger. You get sunshine falling on ground. It does convert to infrared. By the way, if it's on water, it's almost all absorbed. The reason if you fly in an airplane that the oceans look dark and black is because they are absorbing all the incoming sunlight. Snow, on the other hand, is white. Clouds reflect light, and that goes back into space. Here's the, I'm not so sure this graphic is that accurate. This number really should be about 75% because some of the sunlight penetrating a snow field actually does convert to infrared, goes back to the snow as infrared, and also goes back into space, but can get trapped by the CO2. So there's a little complexity there, but I'm not going to spend too much time talking about it. So this is what albedo does. Reflects incoming energy. Here it has to get colder. This is what albedo looks like. The reason I like this particular slide is because NASA's chief scientist comes from here. This is University of Colorado in Boulder. All right, so I kid him about it. This is all sunlight coming in here is basically being reflected. Here is the drilling rig near Barrow, Alaska. This is early March. Sunlight comes in, gets reflected. Again, 70% of that energy is off the planet, goes into space, doesn't come back, and does not get heat trapped. This is what it looks like in summer, by the way. The caribou have a ball. The mosquitoes have a good time, too. But here you have 24/7 total absorption by the ground of sunlight, conversion to infrared, and it does get re-radiated by the carbon dioxide in the atmosphere. This is New Year's, okay? 2007, 2013. Take a look at the difference. Remember 2007 was a prior record snow cover extent. I go down here. This is near Istanbul. You notice there's a big finger of snow in 2013 that reached it. Asia is totally covered in snow all the way down to the Himalayas. All of the sunlight coming is reflected. Moscow this winter had horrendously cold temperatures, 50 below zero. The coldest ever recorded in Siberia was recorded this winter, 98 below zero. It was up here. That's how much difference that snow cover made in the atmosphere of the planet. It had to get colder, and it did get colder. To our British friends who are monkeying around with some of the temperature statistics, and I'll talk to you about that in a minute, this is what England looked like in January. All the way down to London, it is snow-covered. These are the British Isles. They got what they deserved. Okay. Now, here is a graphic that shows that the carbon dioxide is still going up, and yet for the last 15 years, the world average temperature has flatlined. This is the basis of the CPAC ad I showed you when we first started my presentation. CO2 is going up. And why is CO2 going up? Well, first of all, most of the CO2 going up is released from the oceans. Remember, the oceans are still getting warmer. As you increase the molecular motion in the oceans, they kick out the heavier dissolved CO2 molecules. I'm going to show you a Department of Energy slide about that in a second. This is a more telling graphic, and it actually duplicates something that Hal had up before, too. The CO2 is the green, straight, flat line you see crossing the graph. It was around 280 parts per million for the last 1,000 years, actually the last 2,000 years. Going back 10,000 years, it was between 260 and 280. So basically, level CO2. Here you have tremendous warming increase in the medieval warm period. What's CO2 doing? Is CO2 going up? No, I don't see it. Here you have the beginning of the Little Ice Age. Look at the effect of CO2. CO2 has had no real effect on these temperature swings. Now, all of a sudden, we're exiting the Little Ice Age. Humans are starting to add some to the atmosphere through our industrial output. And here you have what Hal called the coincidence and correlation. All right? Coincidence is not correlation. It happens to be that CO2 is increasing at the same time temperature is, but one does not necessarily cause the other. And you can see the great impact that CO2 has had in the past. Not a lot. Here is the telling graphic. This is, maybe I can enlarge this a little bit. It's from the Department of Energy, also IPCC. The natural impact of CO2 compared to the human-made. If you want to do the percentage calculations, human-made CO2 is less than 3%. It's 2.9%. And most of it gets reabsorbed. So the human impact is actually very, very little. The most ambitious project that has been proposed so far is the sequestration and extraction from the air of CO2. The University of Chicago is doing this. The total cost is estimated to be about $3 billion to do so. And what they're going to do is try to extract CO2 from the air and bury it underground. Now, in order to keep it frozen underground, you have to get it to 70 below zero. You need energy to do that. All right? So you're taking CO2 out of the air, you're using lots of energy to keep it cold. Lisa Jackson, when she testified to Congress, and Senator Inhofe yesterday made the same comment, told the truth when asked, what is the impact of this? The extraction of that CO2 would be a zero, a decimal point, 5 zeros before the first one shows up. That's the total impact on the world's CO2. We just don't have the impact, and we don't do enough. That's, by the way, it's $3 out of your pocket, $3 out of your pocket, $10 out of every American's pocket to pay for that minuscule impact. And that's the most ambitious project they have. Now, I'm going to interrupt my talk to talk about what we did at NASA. All right? There's one thing, and I want you to carry this message away too. You know now the impact of CO2. You know what the atmospheric impact is, why it's getting colder because of the albedo and reflectivity. You need to tell people that. And we did that at NASA. we had people like Walt Cunningham. Walt, I call him probably the bravest astronaut we ever had. Why? Because, Walt never, ever stopped trying. He never gave up. We had a disastrous Apollo fire that killed 3 of our colleagues. Walt was the first person to dare to go in the Apollo craft after that fire. He was the first guy. That's a real hero. You want to see a real hero? Look at him. Now, we got another one here. We got Hal, all right? Hal, you heard he helped design the lunar module landing thing. He was the project leader of the project that discovered ways to get rid of resonances between the fuel pumps and the fuel systems in rockets. When these things are in phase and out of phase, they can destroy a rocket on the way up. As the fuel is depleted, the phase changes. This is a really tough problem. Why? Because you can't send somebody up on one of these rockets with a stethoscope and say, hey, here's where the phase change is beginning, and we're going to blow up right now. His team basically saved the life of every astronaut that followed, and there were hundreds of shuttle launches, all because of the work that team did. So here's another hero of the space program. But what was their common characteristic was that they never stopped trying and they never gave up, all right? Now, I'm no hero, all right? But I do share one quality with these guys, and that's called tenacity. I don't give up. When I was writing the code that coded the polynomial regression algorithm, I was getting terrible, terrible errors. Printouts and printouts are all wrong. They're all wrong. I couldn't figure out what was going on. Finally, I made a memory assignment in the computer that clicked, and all the numbers worked out right, and the coefficients were accurate to 12 decimal places and all that kind of stuff. So I feel really good about that. If you use the Microsoft Excel spreadsheet and you use the polyfit function, you're using my code. Every climate scientist in the world uses that, and it's a gift from me. I don't get any royalties for it either. But again, I never stopped trying. I never gave up. Now, you guys have to go out in the world now and explain to people what's going on in CO2, and that's why I have this particular slide up. I'm going to enlarge it a little bit. And this is CO2, well measured. And I want you to look at one certain area here. And this is down here between 1964 and 1966. It looks like CO2 actually dropped. All right, now why did it drop? We had a giant volcano that went off. It's called Agwang. It was in Indonesia. And we didn't stop cars running, but the ocean's outgassing was impaired because of that volcanic dust in the atmosphere. Same thing happened up here. And now we're talking about 1991, 92, and this is Mount Pinatubo. And CO2 also fell off. So the oceans are the major source of that CO2. Here's our slide. God we trust, others bring data. I'm going to show you the recent data. This is the Hadley 3 data. And this is temperature. Why do I use Hadley 3 and not Hadley 4? Well, Hadley 4, the British decided to mess around with the statistics, and they added weight to the areas near the North Pole. And they said, we're doing this because the poles are getting warmer. These ocean currents are warming it up. What they didn't do is add additional data from the South Pole. And the South Pole, by the way, is getting colder. That's now out of that record. So to call it world temperatures really is a misnomer. So here is the new hockey stick, courtesy of Steve Goddard. And by the way, people who say, Tom, you're cherry picking. You know, you're just taking a certain thing. First of all, right here is where I live. I live in the present. I'm not cherry picking because I'm using my own time frame going back in time. And you can see you can go back and go back a couple of hundred years if you want. That hockey stick is still effective. This one has no normalization errors. This one does not take data which is effective, and when it becomes ineffective, adds another proxy on top of it. This is hard, accurate data. It is the hockey stick that you need to keep in your mind. When you explain this to people, you need to realize that even if you don't believe in angels, you're on their side, and they're on yours. This is the truth. It's hard data. We use it at NASA. I don't want any of you to ever think about stopping trying to tell people what you've learned today. You've learned that the carbon dioxide outgassing is the majority of it comes out of the oceans. You've learned that Greenland is not falling into the ocean. You need to be the new missionaries. The angels I talked about, they play hockey too. This is their stick. I want you to make it yours. Never stop trying. Never give up. Never, ever give up until the world gets it right. Thanks.
Thanks, Tom. Thanks, everybody. We have time for questions and answers. There's a microphone right here. Just raise your hand and we'll point you out and get some questions.
The science, you're pointing out the direction the science is going. There's still a question of how you disseminate that to the public. I mean, I have friends, liberal friends, we talk about the subject, and they say, well, I read in the New York Times, you know, that global warming is terrible, and, you know, I can only quote the Washington Times. But are there plans to somehow disseminate this information more broadly than it is now?
Let me answer that quickly. That's really what the Right Climate Stuff group is trying to do. We are letting people know what the truth is. I run around all over the place and give these lectures. I have about 40 speaking engagements every year. We have symposia down at NASA Houston where we invite speakers from, quote, both sides. The ones from the other side aren't winning because the hard data is on our side. Walt showed you how there's only a small sliver. We are actually within the noise of the last 10,000 years. So these temperature fluctuations you're seeing are very, very unremarkable. I could show you a slide that actually supports Hal's point that these things are all local.
Tell you what, though, Tom,
Sure.
let's move on to the next question.
Okay.
There are a lot of educational
Sure.
efforts taking place by Heartland, CPAC, and other groups. You know, Google the issue and follow it. So, next question.
Yeah, just wanted your insights. In a past life, I was a hard rock exploration geologist, and it just seems like the root of this problem is very long, and it seems to me to come back to the quasi-religious environmentalism that our public schools teach. Just want your comment on that. And what we can do about it.
Walt?
I think you touched on the key to many, many problems we have, not just about this. And what it comes down to is in schools today, in fact, it's our fault. We've raised 2 generations of people going to school who are not taught to be skeptical. They're not taught to challenge things. They're supposed to buy into what they've been told. So until you start letting folks know and raising your kids and getting the schools to do that, we're not going to have skeptical thinkers. And it takes skeptical thinkers to not buy the nonsense that we keep getting fed day in and day out, and not just on global warming.
Okay.
I just have a quick question. I know most of your discussion was today about global warming and CO2, and alternatives to CO2 could be some natural gas. But what is your thought process on the issue of frac sanding going on, and is the positives maybe outweighing those negatives?
Excuse me for injecting myself again, but it's some of the most nonsensical stuff that I've heard. I don't go in and study the science so much as I read both sides all the time. I don't have a political axe to grind. I could care less who does it if they don't do it right. And the first article I ever wrote on that had anything to do with this was back in, probably before the 1990, I guess. And I'm talking about the correlation between energy consumption and our standard of living. Now, anybody that's old enough, like me, will know that that standard of living relative to the rest of the world has been slowly falling, and if you want to draw a correlation, it's because we've been raising so much trouble about this. If we have a problem with any kind of energy generation, we should be addressing that problem, not turning it off so we can have people out there trying to dream up the alternative energy. I was on the board of the National Renewable Energies Laboratory for 5 years. And I was kind of a isolated member. There weren't too many of us on there like that. But there was not one bit of renewable energy consumption of any significance that had any economic justification for being there. Now, I happen to believe that when it's economically justified, one, you'll get money invested in it because you're looking for a return, and you might eventually will start driving the cost down. I had my own venture capital fund for 12 years, and I can tell you this, if it's got any economic soundness to it, it will get developed.
I have a quick comment in reference to what I didn't see up here today, which was the effect of sunspots. And one thing that, the physics of the whole thing is the atmospheric pressure on the ocean, around the entire world, as the case might be, now 14.7, whatever it happens to be. As those sunspots generate more energy, the atmospheric pressure would be lessened, thus more CO2 would be released from that ocean. And I just thought that there might be a correlation between what the sunspots have done in reference to some of the other slides that you've given.
Walt, you had a slide that showed the correlation between sun very, very cleanly.
Solar irradiance, and I hate to go back to something I argued against, correlation is not necessarily causation, but if you look at the correlation between solar irradiance and temperature, it impresses me.
Sir?
Isn't water vapor a major gas in this? And it's
Yes.
25 times what carbon dioxide is, and it's also has more strength in the. And every time I ask one of the scientists that says this is a big problem, they don't want to talk about water vapor at all. They just got upset.
That is correct, yeah.
Well, water vapor is the major greenhouse gas on the planet. The only implication that the so-called AGW crowd can bring to bear is that carbon dioxide has increased in the last about 40% since the industrial age began, but the effect on temperature itself is almost negligible. That's why I put that CPAC slide up. So they're hoping to they can't control the water vapor, and they're assuming that they can control the CO2, and the fact is they can't.
But, Tom, one of the things they do in order to get the impact of carbon dioxide to make their models work out, they have to have say that turns on the water vapor effect on it. So they pull in that in order to try to make their models work.
Yeah, the climate models really use water vapor to amplify the very tiny theoretical effects that CO2 would have. And that's all, in my view, conjecture, because they really don't know what the response of water vapor is to a little bit of warming. Now, I think there's a correlation between water vapor and clouds. And if you get more clouds, you get more albedo, that drops the temperature. So that's why the climate models need to get validated. They don't handle clouds and they don't handle water vapor very well. They don't handle the water cycle. Evaporation, condensation, it's a big heat transport mechanism that they don't do well.
Yeah, it includes hurricanes too, which are also giant heat transfer mechanisms from the equatorial regions into the northern hemisphere and southern hemisphere. The thing is, there is no climate model yet that uses past data that you can turn back about 8 years and say, predict the present. It doesn't work. They don't predict well.
Ma'am?
I went to a conference a week ago, sponsored by Cornell, which stated posited as fact how climate change impacts elderly people. And then rather than discussing the facts or the science of climate change, which I tried numerous times to bring up, it was only for journalists, and nobody but me seemed to even ask, well, the definition of this conference is ridiculous because you haven't proved the supposition to begin with. And when I brought it up, the woman said, oh yes, but she did not respond to the question. The other thing that bothered me is that I've seen a film called Chasing Ice, which is a longitudinal, quote unquote, supposition that the ice shelf is melting based on 3 huge years, 3 years of ice melting, and these are not scientists, but somebody tricked me into going to the film, pretending we were going to a different film. And I was really annoyed with him because he doesn't want to read any facts. He just wants me to acknowledge that he's right in that climate change is a reality. Thirdly, there's a conference I went to in England which said that if we spent $250 billion, we could change the temperature of Munich 1 degree for 1 hour.
It might even be correct. By the way, I had to review that film, Chasing Ice. There's some spectacular imagery in that film of glaciers breaking up. However, at various points in the film, they make unsupported statements that humans have caused this, but there's no connection to it, no connection to the physical effect of the ice breaking up. There is a connection, which I can see as a scientist, that the ice that they focused on happened to be ice that had dirt inside it. Well, that dirt, as the sunlight penetrates the ice, converts to infrared and melts it a lot faster. So they happen to take some pictures of dirty ice, and those are the ones that they show you.
But the thing that bothered me is that they said at a certain point there is no going back, which I think is not supported either. They showed that it was going down. And we know climatologists and geologists say this happens, a sine curve.
All right, but remember,
But they said no, there's no going back.
but remember, glaciers are ice rivers. Rivers don't go back. So that's correct, okay? So the ice that falls into the ocean, yes, it's going to stay in the ocean. However, as you noticed in the slide before, interior Greenland is accreting ice and snow, which is what's feeding those glaciers. So yes, they won't go back, but the Hudson River won't go back either.
Question over here?
Yes. So I live in California, and obviously there's some significant issues, cap and trade and all that. They've decided that they want to have 1990 CO2 levels by the year 2020. Can you see any significance to why they would pick 1990? And in addition, one of their solutions is to really pursue solar. We've seen a lot of that. But also in research, it says that the solar panels and things are toxic waste when they're at the end of their useful life. So do you think that there are any legitimate cases to be made for solar as far as netting their benefit and also the 1990 issue?
I think all of those various alternatives should be researched. We should be looking at trying to get knowledge about them the best we can. There may even be a time, 90 or 100 years from now, when it makes economic sense to do it. I grew up in Southern California, and that's why I'm glad I moved to Texas 50 years ago.
Hey, let me add a little to that. The targets that you hear about, like for instance 350.org, they are just pulled out of the air. They have no meaningful relationship to what climate should be or could be. And in fact, if you notice, CO2 hasn't changed the temperature in the past. They are basically meaningless. I tell people sometimes they are pulled out of places with fecal material attached, and you can figure out where that comes from.
I think there was only one time about 300 million years ago when temperature and carbon dioxide were as low as they are now.
We have time for a couple more questions.
Thank you all first for your work. We saw where CO2 really shot up, and I know there's not a correlation, but why did the CO2 suddenly jump up in the last several decades?
I have no problem understanding that we are contributing some with industries and things like that. The oceans are still getting warmer. Remember, you're coming out of the little ice age. The oceans got warmer, they release more CO2. And by the way, the oceans are now, that warming increase is beginning to level off. You may see some CO2 leveling off too.
You know, if CO2 were cyanide, I'd be worried about it. But I mean, we're not saying that humans aren't contributing to CO2.
And we also-
Most of us think that's a good thing because it's good for plants. It's way below. I mean, we're talking about 395 parts per million now. We allow 8,000 parts per million on submarines.
Right.
So we're not anywhere close to a problem. If you put it on a graph and you look at what percent of the atmosphere we're talking about, it's a few hundredths of a percent.
And we were allowed not 8,000 parts, but a very high number on the spacecraft when we flew on them with the carbon dioxide. Secondly, we're involved in the longest interglacial period in history. We've never had 10,000 years like this where it stayed so flat. We're fortunate. We're long overdue for another ice age.
Yeah, that's the real concern.
Well, no, don't say it doesn't have an effect. CO2 can affect temperature, it doesn't control it. In fact, I'm seeing right now, if you're looking for what controls it, albedo has taken forefront in what's controlling temperature, atmospheric temperature on the Earth. And if you have a cold atmosphere, which we do have now, you're going to get cooling oceans, and that's reflected in the data. You know, we like to use data at our NASA group, and that's where we draw our conclusions from.
I'd like to make one quick point on that. Climate scientists always talk about what will happen if we double CO2. We have members of the National Academy of Engineering on our Right Climate Stuff team that come from energy business. They're worried about running out of fossil fuels before you can double CO2 due to human causes. So really, this is a short-lived issue. We're going to have to convert to alternative fuels at some point, and we're never going to double CO2. And it's already at this tiny little level that is inconsequential. So this is a big boogeyman that somebody's creating, and you need to fight it.
One more question we have time for.
I often see the statistic regarding the CO2 concentration in ice cores, but for this to actually indicate anthropogenic CO2 increase, the nitrogen and noble gases would also have to remain stable in the ice cores and the O2 to proportionally decrease. Have we seen that?
I had a hard time understanding, but
I think he's talking about measuring the other gases that would be in the ice cores. And we're dealing down in such tiny changes that I'm not sure you could track all those things myself, but I'm not.
yeah, I think they've realized that getting CO2 concentration from ice cores is a difficult task. I think a lot of more work needs to be done.
Okay, thank you for that answer. Thank you all for being here. So a round of applause for our panel. These gentlemen, of course, will be sticking around to answer more questions. You may see on your seat this right here. This is the citizens' petition to rein in the Environmental Protection Agency. The Heartland Institute has been promoting this. We've collected 16,000 signatures so far and presented them to Congress. When we get to 20,000, we're going to do it again until they get the message that if the EPA is going to be out of control, the way you stop that is by controlling the purse, and by pulling out the money, you make them smaller and less influential. And if the people can demand that, maybe we'll see that happen. Walter Cunningham's booklet that you have there is also available outside, and I'm sure Walter would be happy to sign somewhere on there for you. And all the materials that you see on the table outside this door are free for you to take, including the T-shirts, materials from our previous climate conferences, and the book Roosters of the Apocalypse, which is a good look at the hysteria in academia and in the public about what's really not a problem, as discussed here in this panel. So thank you all very, very much for being here, and I hope you have a great rest of CPAC.